When I was 13, my brother developed this tendency to raid the pantry. He was 2 years younger than me and had always had a healthy appetite, but this was different. He was just demolishing the juice boxes, whole flats of them from Costco, one box after another. This came to a head on a holiday road trip when we had to stop every half hour because he had to use the bathroom constantly. Then he got sick. Some kind of virus or something. And the symptoms were so bad that he ended up in the hospital. And there, they checked his blood sugar, and it was sky high. My brother had diabetes. That means that my brother's pancreas wasn't making insulin, a hormone it needed to break down sugar, or glucose, from his food. So that glucose built up in his blood and forced his kidneys to work harder to filter and absorb it. Eventually, that extra glucose was dumped into his urine, and it took fluids from his tissues along for the ride. That's why he was so thirsty, and that's why he needed a rest stop every 30 miles. That part made sense to me. I mean, food, kidneys, urine, it's all part of the digestive system, right? But as we as a family learned more about my brother's new lifelong condition, we learned about other risks that didn't make as much sense. Like, why would diabetes come with the risk of blindness? And why does my brother need to see a special podiatrist for his feet? It turns out that the effects of insulin aren't just limited to your digestive system. Too much glucose in the blood can damage blood vessels and nerves, like the ones in the eyes and in the feet. The same goes for the testosterone and estrogen therapies that people might need as they age, or the growth hormone a child might need when they're not growing the same as the other kids in their class. This stuff doesn't have just one effect. Hormones are more complicated than you think. And today, we're going to talk about how hormones control us, even while we attempt to control them. I'm Ashley Hamer, and this is Taboo Science, the podcast that answers the questions you're not allowed to ask. We talk about hormones like they're simple. Estrogen is the female hormone. Growth hormone makes you taller. Adrenaline makes your heart race, and melatonin makes you sleepy. But very few of them work in isolation.
One of the things that we're really learning now is we tend to think of all these hormones in silos. And the more we learn, the more we realize how much they interact with each other. I am Randi Epstein. I'm an author, most recently of Aroused, The History of Hormones and How They Control Just About Everything. I'm also a lecturer at Yale University, an adjunct at Columbia University, and I'm the writer-in-residence at Yale School of Medicine.
I'm a big fan of Randi's book, and one reason is that in it, she explains hormones in a way I've never heard before. And I kind of understand them in a whole new way.
Hormones, I like to say that they're your internal Wi-Fi. And I say that because the way hormones work, as opposed to everything else in the body, is they are little tiny packets of chemical information, of chemicals that are secreted from a gland and then target far away places. Now, I don't mean far away like from New York City to Asheville or to California. I mean from your brain to your ovary, from your brain to your testy. So that's just the definition. Secreted by a gland, reaches a target. It kind of sounds like no big deal because we're so used to hearing things about receptors and the way the body works. But here's why it is a big deal. Before we understood hormones, the thinking was that every message in the body traveled along nerves or floated through the blood and just kind of went this way and that. But hormones are like, I say Wi-Fi, and I have to tell you, I'm pretty ignorant about Wi-Fi. I know more about hormones. But for like when I send an email, like I type it up, I'm sending it from my computer, and it's going to a specific target, even though it's sort of floating out. And that's what your hormones do. It comes from a gland in your brain, and they don't just sort of get showered all over to land anywhere in your body. They have to reach a target. So that's what makes it a hormone.
Yeah. Well, how do they reach that target? How do they know?
They do go through the bloodstream, and they reach them by receptors. So estrogen gets released. And we know that there's estrogen receptors, in the uterus, and your ovaries release them. But now we're finding there's estrogen receptors in your brain. So they can only go to the cells that have the target for them. So it's not just that they go to one place, but they have to go to those receptors. I think people that have taken biology in school learn this lock and key, which is sort of a cute way to learn the way, like if the hormone is the key coming in, it has to fit into the lock on the door. It's actually a little more complicated than that as things go. And I write about this in the book that because it took me a while to understand this, that it's almost not like a lock and a key, but two people dancing and someone cutting in. Because there's like receptors have some strengths and weaknesses. Hormones have strengths and weaknesses. So if you think of two people kind of dancing in a, crowded club, and we're getting there, we will have crowded dance clubs soon. There might be someone stronger that pushes away a dancer and comes in and may cut in on two women dancing, and some other woman comes and is like, nope, I'm getting in, and edges it away. Or maybe the couple that are dancing is like, nope, we're sticking together. So I like to think of hormones like that because it gets that much more complicated in terms of it's not just this lock and key. It's they're stronger and weaker. And I'm giving this weird dancing metaphor because I also think it helps explain why, as wonderful and fascinating, and I hope that I explained a lot in the book, I also think that it's going to be always very difficult to have one blanket statement for the entire population to say this much of this hormone will make you feel like this, because it all depends on your individual strengths and weaknesses of receptors, the number, the strength. We're also individualized in the way we handle all this chemical brew.
And with them seeking out these receptors, that's basically how medicine works, right? Like when we take a pill, that's what happens?
Yeah, and it's funny you say that because when the doctors in 1905 named hormones, someone else in the audience, because it was like someone was giving a talk and was like, hormones, as we shall call them, from the Greek word that means hormoa, to arouse, because they excite. And someone else in the audience, this was in 1905, another doctor said, no, I have a better word. They should be called autocoids, internal drugs. And so, it is the way a lot of drugs work. And a lot of people will say your hormones are like some weird internal drug.
But to really get into the history of hormones, we have to go further back. About 50 years further to Dr. Arnold Berthold and his rooster experiment. Buckle up. This one's a doozy.
It's considered the very first hormone experiment. And I do have to say, on my website, I had, and this is done by two of my students who did this on an iPad. They actually did a little animation of this little story, and I thought they did the best job ever. And they're not artists; they were, science students. So if anyone wants to see the rendition of this, and I'm really proud of my students to do this. So, and that's on my website, randyhutterepstein.com. But here's the story without the fun illustrations. I wish I could have just pulled it up with the music and all.
You can find a link to that video in the show notes so you can watch it for yourself. We're not going to play the music from that video, but we'll do our best.
In 1848, we knew nothing about hormones. Everything was like along nerves. Anything we knew about the body was basically like just mapping it out. We didn't really, chemistry, physiology, those fields came along later. This German doctor, Dr. Arnold Berthold, in his backyard, just started wondering. People were wondering about testicles and ovaries. And remember, farmers would castrate their cows. We kind of knew there was something potent in testicles. But what he did was he wanted to know, basically, if you took a testicle and you implanted it anywhere in the body, would it still do its jobs? So he had these roosters, and he castrated them.
He took 6 roosters and cut both testicles off of 2 of them. He cut a single testicle each off of another 2. And in the last 2, he cut the testicles off of both of them, but then surgically implanted one in the belly of the other. So each had the other bird's testicle hanging out around its intestines, far away from where the testicles usually are. And by the way, if you're wondering what I was wondering, yes, roosters do have testicles, even though you've probably never seen them. See, a rooster's testicles are actually inside its body, near its backbone. So when Berthold put them in the rooster's belly, even though they were still inside the body, they were in a very different place. So, what happened? Well, the fully castrated roosters didn't do so well.
And as he said, his castrated roosters got fat and lazy, and he said they acted just like hens. We can hold that against him. Because I'm sure the hens were a lot more active than those damn lazy roosters most of the time.
The roosters with one testicle, though, they did just fine. They acted like their old roostery selves. Berthold found that the single testicle had increased in size, probably to make up for its lost brother. And the third pair, the Franken roosters with testes in their bellies, that was the most impressive of all.
And what he found was that rooster grew back to that male rooster it always had been, chasing the hens, getting its energy back, probably being condescending to all the hens, I'm assuming. And then he wrote this scientific article that really was the first explanation of hormones. He said it was a German article, and he wrote that basically whatever juices are coming, secretions from this gland, it is getting its target, and it can do its job no matter where it is. So we know that now, because we know if you're a diabetic and you have to take insulin, you don't have to inject it right into your pancreas. You can inject it wherever, and the insulin will go where it wants. But here's the thing. I think that, what makes great science is like coming up with these questions. It's not the answer, it's the question. So he had this great, fabulous question. Can I put this testicle anywhere in the body, and will it do its job? Yes, great question, phenomenal. Did the experiment, and did another experiment that confirmed his first one. So that was great. Did the whole scientific process, wrote it up in a scientific journal. But the one thing he didn't do was really appreciate the ramifications, like that he just discovered this whole new way the body worked. He published it. It went into a dusty old, journal somewhere, and that was that.
And Berthold moved on to other pursuits. In the video, there's this great quote from Albert Hugh Maisel, who says, "It was as if Columbus had discovered the Americas, turned back, and spent the rest of his life studying the streets of Madrid."
And it really wasn't uncovered for another half century. that doctors started looking into the chemistry and physiology of the body, and somebody dug up this old German article and was like, oh, wait, this guy was onto something. Maybe we should do more research into this.
Eventually, scientists started to figure it out.
As things do, there's gradual research. And here's what I like to say. Like, a lot of people will say that there's this guy, Claude Bernard, in 1855, who talked about internal secretions. And a lot of people say he was the father of endocrinology. But I don't really think so. I mean, I think he's a brilliant father of something, pioneering researcher. But it were these researchers in England in 1905 that named hormones. And what they brought to the field were a few things. One is they said that these things don't just secrete. That's why they wanted to name them hormones after the word aroused, and hence the title of my book is Aroused. And they weren't just thinking sexual arousal. They were like, these hormones ignite. They ignite the adrenals. They ignite the pancreas. They're not just secreting. There's more action to them. But then the other thing that they realized because of this action is they really unified this field. So in the 1800s, there were people trying to figure out, what do the adrenal glands do? What does the thyroid do? What does this pituitary in the brain do? There were people that were doing autopsies and seeing these glands and trying to figure out. But it wasn't like the thyroid people were talking to the adrenal people who were talking to the testes people. It would be like, dentists saying that dentists and, dermatologists should be the same field. Like, that's how different it was. Like, why would people that study adrenal gland have anything to do with people that study the pituitary? But in 1905, when the mode of action of hormones was discovered and appreciated, that's when these researchers were like, wait, there's like this commonality, and maybe these glands interact. And so that really started this whole field of endocrinology. Because when you think about it, when you think about hormones and endocrinology, it's probably one of the vast medical specialties there is, because it deals with so much versus you're not just dealing with like the brain or, the foot or bones. You're dealing really with the chemistry of the body, which is vast.
Yeah. I mean, most other systems in the body work toward a similar goal. The circulatory system gets oxygen-rich blood to the body. The digestive system gets nutrients out of food. But the endocrine system? It's made up of 9 glands that produce 50 different hormones. And all of those hormones do different things. So, first, you've got your pituitary gland.
The pituitary gland is in the brain. And I like to think of it, it's really dangles off the brain. It's off the brainstem and it dangles like an upside down lollipop. And the pituitary has 2 lobes. And each lobe controls different things. The pituitary deals with a ton of hormones, like growth hormone and another hormone that helps your salt balance. So if you have too little, you might be draining salt. So it deals with a lot of those things. Growth hormone, it controls estrogen. It controls a lot of controlling hormones come off your brain.
There's also the hypothalamus.
Your hypothalamus is also in your brain. So your brain has a lot of the control stations that will then trigger the thyroid to release its hormones, or the testes. So you have that.
Then there's the thyroid gland,
which controls a lot of metabolism. And there's probably a lot of your listeners might have thyroid issues. And so people that have problems with their thyroid, if there's too much thyroid hormone, you might feel super jittery. If there's not enough, you'll feel really tired and really slow, and you might start gaining weight more easily. So that's your thyroid gland in your neck. And that's why when a lot of times, or you should, when you have your checkup, you'll notice your primary care physician sometimes feels your neck, because it's pretty common to get thyroid nodules or to have something that can impact your thyroid gland, which can affect your metabolism. Then we know we have your testes and your ovaries that do a lot with reproduction. Your pancreas, which controls sugar. It has to do with your insulin. And then your adrenal glands, which we have the hormone named adrenaline or epinephrine, and cortisol, which we tend to think of as your fight or flight and your stress hormones that are coming from your adrenal glands.
There's also the thymus, which produces white blood cells to help your body fight off infection. And finally, there's the pineal gland, which honestly has always sounded dirty to me. Is that just me?
That has this long history that they used to think the pineal gland had something to do with morality. Now we think it's more to do with circadian rhythms. But there were times in history when they thought it was something hormonal and they thought it was sort of your moral center.
All those glands, and that's just our current knowledge. There might be more parts of your body making hormones that we haven't discovered yet.
And then one of the things that really shocked me when I was working on the book is that we realized that the fat cell also releases hormones. We tend to think, oh, there's these 9 glands. But I think the more we learn about hormones and endocrinology, the more we're going to see that other parts of the body might be releasing hormones or are receptors to hormones.
And these hormones don't act alone. They interact with other hormones in your body.
Like cortisol, we think of as the stress hormone, but it really has to do with your immune system too. So it's closely intertwined with your immune system. When things go awry with growth hormone, it might mean that it doesn't just affect your vertical climb, too short or too tall, or shorter than you might have been, taller than you might have been. It can affect the onset of puberty. So all these things are really tightly connected. So in some ways, and I think one of the impetuses for me to write the book was I'm fascinated and I admire some of these endocrine researchers who have made such huge advances. I mean, it's amazing the help that we can give people today who, 100 years ago might not have survived.
But as that science has developed, there have been some real tragedies along the road. One of the worst was in the use of human growth hormone.
Originally, and this was based on animal research, as a lot is, we saw that if you purified the growth hormone from pituitaries have lots of hormones. If you purified it and you gave it to another animal, it would grow. Then we thought, insulin we got from cows, we got from cattle, and you can give insulin to humans from wherever animal you get it from, and it will work. So the thought was, let's just get a bunch of growth hormone from cows and we can give it to people that have growth hormone deficiency. Well, growth hormone doesn't work that way. It has to be species specific. So you have to have human growth hormone. That's why we call it human growth hormone, HGH. It has to go from human to human. So originally, if you go back to the mindset of the 1960s, we were getting growth hormone from pituitaries, and it took, one pituitary provided just a little bit of growth hormone. So you would need hundreds of pituitaries just to keep someone who is lacking growth hormone. They would need hundreds of bodies a year to keep them going. And we're talking dead bodies. You can't it's not like a kidney that you take one out and can donate. You get growth hormone from pituitaries of dead people. Now, looking back, we can think, wow, weren't we worried about lurking viruses or other things going into the brains of people? There were some people that worried, but the general feeling in the 1960s and 70s was it was much more natural to get growth hormone from the brain than to weirdly synthesize it in the lab. In the early 80s, when this tiny company was saying we can make synthetic growth hormone, the feeling was that's scary. Synthetic, lab made is scary. We want it all natural from the pituitary. What I write about in my book was this horrible tragedy that it turns out that some of the pituitary glands were not purified correctly. They did have lurking deadly diseases in it, and that there were some people who died as adults from weird brain diseases called CJD. That's the same disease as mad cow disease, as Kuru. They died as adults from the growth hormone they got as children because they had this slow, fatal virus implanted in them. And it's a real tragedy when we look back at what was going on. And it also shows sort of our cultural shift to realizing, actually lab-made things don't always necessarily mean scarier. as soon as we discovered, and it was some real heroes that made this discovery, because you're looking at adults that seem to have a random disease. It wasn't a huge epidemic. It was a few cases. It was a low number of cases compared to the thousands of people that took growth hormone. But it was some really wonderful and astute doctors that made the connection, eventually led to a ban on pituitary growth hormone, the growth hormone from brains, and greenlit this teeny tiny company that then became Genentech. So Genentech exploded. So as one doctor said, the whole world was mourning except for Genentech. They got the green light and they've been saying all along, we should be making growth hormone. And then as soon as it was banned, people listening to this now do not have to worry that if they have a child that is on growth hormone, it is 100. We do not have pituitary growth hormone at all. It's been banned since 1984. 100% of growth hormone now is synthetic. And actually, the studies show that the growth hormone that's been given since 1977 was from a lab that so far, even the pituitary growth hormone made from 1977 to 1984, there have been no cases of CJD from that processing. It was the pre-1977. But it's not ancient history. People that are probably my age and a little older, I'm 58, if they got growth hormone in the late 60s or early 70s, they or their family receives a letter every year from the FDA saying, have you had any symptoms? Please report if you've had any of these brain disease symptoms.
You might think that it's silly to take all these risks just to help your kid grow a little taller. But like many hormones, that's not all that human growth hormone does.
I mean, for some people, yes, it was when they were going to be much shorter than norm. But some people, if they are really low growth hormone, they might have issues with going into puberty. So it's also to kick in the other hormones that you need, growth hormone, you need the mix to work together. But of course, like anything else, once we had a drug that can make you grow taller, there was this and continues to be this huge push for people who want their son to go from 5'6" to, 6'2". The thing is there's no guarantee. You have to have it before your growth plates seal. So you have to take it early enough. Growth is a funny thing because while doctors, when you're little, will say, oh, you are probably going to get to be this height or that, it's not exact. So it's very hard to say. And there are people that, yes, growth hormone does give on a few inches. How much? It's always hard to say. And, you can talk to people like my husband, for instance. He was my height, which is short, like 5'2", until he was a junior in high school. And then he had a growth spurt and shot up like 6 or 7 inches. And if he had taken growth hormone, we might have credited the growth hormone with that growth spurt. So it's very hard to look at the growth hormone. And I just think my feeling is from reading and delving into the history and talking to tons of experts and patients, I think if you're lacking a hormone, I think it's wonderful that we can provide it to you. But I worry about if you're not lacking, taking an extra hormone to get an extra boost, because I worry about this domino effect of how they'll all interact with each other.
It really is wonderful to see what big strides we've made in the field of endocrinology. But like any field that's on the cutting edge, the amount of stuff that we still have to learn leaves room for con artists and snake oil salesmen to come in and fill the gap.
People just can't help themselves. They hear a seed of some scientific evidence and right away they're trying to sell some cure. I mean, we've seen it with COVID, but with hormones, there's just something so alluring. I think there's something so alluring to some charlatans to say, oh, I can cure you of this and that. And then from the consumer side, it's just so tempting when someone says, I can balance your hormones and you'll be less tired. Do you wake up exhausted in the morning? Do you come home from work tired? Do you think you could just use a little boost on your libido? I mean, I have the pills that were going to make you feel better. It's so hard to resist that. Who doesn't feel tired in the morning and then tired at night? Who wouldn't want a little boost of libido or boost of their metabolism? So, we get these seeds of real science of what the hormones do. And then sometimes there's a leap too far into the wellness industry of it all. It's a lot of money sometimes, and it's a lot of false cures out there. And some of the stuff that you can buy online, I don't even know if there's even any stuff in it, or there could be stuff in it that could be dangerous. You know, thyroid was sort of grandfathered thyroid because it's not really considered a drug. You know, you could get it from an animal. You know, you can actually put thyroid in things that's over the counter, and too much can really make your heart start racing. So there's dangerous side effects too from all of this. You know, I always tell people, you want to make sure the person that's helping you with your hormones has studied endocrinology from a place that is licensed or recognized by the American Medical Association, not from some sort of anti-aging organization, not from some whatever. You know, any doctor, anyone with an MD really could hang up a shingle and sell whatever they want, but I think you want to make sure they're an OBGYN or an endocrinologist or a urologist or someone that spent some time studying the science of hormones so that they'll be aware of the side effects. You know, if someone can tell you that this is all natural and it will do X, Y, and Z, if it's potent enough to do X, Y, and Z, it's probably potent enough to do A, B, and C, which could be a dangerous side effect. You can't have something that's potent enough to heal without worrying about any side effects too.
So to me, it feels like the most misunderstood hormone out there is testosterone. It's like people believe it has this magical power to make men manly and competent and strong and attractive to women. And to get it, you need to do things like eat steak and lift weights and avoid soy. I mean, is that true? Kind of. Steak has vitamin D, which is linked to testosterone production, but so does tuna and milk and even beans. As far as soy, it contains phytoestrogens, which are estrogen-mimicking compounds that are made by plants. That's what the phyto in phytoestrogens means. There's been some concern that phytoestrogens might lower testosterone levels in men, but a 2010 analysis that looked at 16 different controlled studies found that this concern was unfounded. Soy and other plant-based foods are good for you, no matter who you are. But the bigger problem is that testosterone, the male hormone, it's not just in men.
Even the original researchers said we should not be talking about testosterone if it's a male hormone, and we shouldn't talk about estrogen if it's female, because both genders have both and in different amounts. And even some of the discoverers of this chemical said, let's not name it after the testes because the ovaries have some testosterone and it's going to misconstrue what testosterone does. Now, that said, if a man is really low testosterone, and that I mean, we go by the numbers 300 to 800 or 900 nanograms per deciliter, I think it is. If a man is low, and I mean below 300, and that is 2 blood tests taken by an accredited lab, because obviously if you just go to any hokey place, they might do your blood and say, it's low. If you're really low and then you take testosterone and you're a man and you go from really low into the normal, you will feel less fatigued, you will gain muscle mass, and it will boost your libido. But playing with those numbers in between the normal range, studies have shown it doesn't make that much of a difference. And, there are men that pound on the testosterone and say it makes them feel much more irritable, the people that intentionally overdose for weightlifting. So there probably are these real side effects, but it's very hard to distinguish sometimes the aspirational of what you think the hormone is going to do versus, what it really is doing. So it really does have potent effects. It also increases the number of blood cells you have. So there's a risk of heart attacks. There's a risk of stroke. So you really just shouldn't just be pounding up on the testosterone. But I think there is this lore now that there's testosterone gel out there. There was this silly survey basically that said to men, if you feel tired at the end of the day of work, if you get home and you think, oh, you would rather just sit and have a drink than, be able to deal with your kids, these may be signs of low T. I mean, no, that's a sign that you just worked a whole day and maybe you have kids and work and other stuff going on. So we kind of have to figure out, what is real highs and lows. And again, it goes back to then see somebody with real medical training who can monitor and who isn't going to be overdosing you on something.
And then speaking of testosterone, I wondered if you had an opinion about the female athletes that have been banned from the Olympics for having too high of testosterone levels. Have you heard about this?
I have heard about it. And again, I'm not an expert on this, but I find it very distressing where we are going to start cutting off what's allowed and what's not. I find it very upsetting for these women, especially whom they might have been potentially diagnosed with some difference in development when they were younger that gave them more testosterone. I'm not quite sure, in one of the runners, I think some of the studies have shown that it doesn't have that much difference on speed. But then where do we draw the line? Where do we draw the line to say, well, this swimmer might have had Marfan syndrome, which gives you more webbed toes and more flexible limbs, or that basketball player is way too tall. He must have more growth hormone. I mean, I kind of think most Olympic athletes probably have some strange chemistry going on that gives them some weird exotic ability. And then where do you draw the line of what's acceptable and what's not? I'm not an athlete. I was never a professional athlete. I understand that some people might think it's not fair in some ways, but I'm just not sure then where you make that cutoff. And it just seems to me funny that we've only had this unfairness come out for women in sports. We've never looked at any men that might have something unusual in their chemistry to give them an advantage. And I just think that at that level, everyone's got some inborn advantage.
In the end, there's still a lot of mystery to hormones. And hormones probably control us much more than we realize.
Well, I think one of the most fascinating things that I touch on at the end of my book is that we think of hormones as sort of growing immune system, these basic things, but we're really learning how hormones control our drives. So even when we talk about the obesity epidemic and leptin and ghrelin, those hormones we used to think, well, some people have faster, slower metabolism, but we're also realizing that some people have more of the drive to eat. And it doesn't just have to do with food then it's making researchers now think about what urges, what compels us, what do these hormones do that influence our personalities, which I think is fascinating. That's why, the book is called The History of Hormones and How They Control Just About Everything. We are our chemicals. I like to think that I'm above it all, that no, here's me as a personality, and then I'm the puppet master of my hormones. But it's kind of sort of the other way.
Thanks for listening. Taboo Science is written and produced by me, Ashley Hamer. The theme was by Danny Lopatka of DLC Music. So many thanks to Randi Epstein. You should definitely check out her book. It's called Aroused: The History of Hormones and How They Control Just About Everything. There is way more in there, from a medical explanation of old-timey freak shows to some truly weird pseudoscientific cures. You can find a link to pick it up in the show notes. If you have a topic that you'd like to hear on the show, shoot me an email, ashley@tabooscience.show, or just hit me up on Twitter. I'm @SmashleyHamer. I would love to hear about the things you want to know and the weird taboo topics that you'd like me to dive into. And as always, the next episode will be out in 2 weeks. Catch you then.